Hello everyone. Today we will introduce the high voltage load switch. We will mainly cover three aspects. The first is an overview of high voltage load switches. The second is the structure types of high voltage load switches. The third is the usage knowledge of high voltage load switches. In this lesson, we will mainly introduce the function, the structural requirements of high voltage load switches, and the structural characteristics of gas-generating load switches. Totally three aspects. A load switch is a switchgear used to cut off and connect circuit under load current. Some can also be used to cut off and connect no-load circuits, no-load transformers, and capacitors. The load switch in the open opposite has a visible break, which can act as an isolating switch. At the same time, it has a quick closing mechanism and arc extinguishing device. Its performance is better than that of isolating switch. It is a switchgear that lies between isolating switches and circuit breakers. Let's look at the function of load switch. A load switch is a switchgear with a single arc extinguishing device that can break and close rated load current, but cannot break short-circuit current. Its functions are as follows. The first is breaking and closing function. Since the load switch has a certain arc extinguishing capability, therefore it can be used to break and close load current and overload current of less than a certain multiple, usually 3 to 4 times. It can also be used to break and close no-load transformers with great capacity, then allowed by the isolating switches, no longer load lines, and sometimes to break and close large capacity capacitor banks. Second is substitution function. A load switch in series with a current-limiting fuse can replace the circuit breaker, and the load switch handles breaking and closing overload currents less than a certain multiple, while the current-limiting fuse handles breaking large overload currents and short-circuit currents. A load switch in series with a current-limiting fuse is called a load switch fuse combination switchgear. The fuse can be installed on the power supply side of the load switch to protect the load switch itself from short-circuit accidents. The fuse can also be installed on the receiving side of the load switch to utilize the load switch as an isolating switch to isolate the voltage applied to the current-limiting fuse. If frequent replacement of the fuse is not needed, the former arrangement is preferred, otherwise the latter arrangement is better. Fuse combination switchgear can functionally replace a circuit breaker since the current-limited fuse is a single-use device. This replacement is only suitable for places with low voltage, small capacity, and not very critical applications. The price of this combination switchgear is much lower than that of circuit breaker, which can effectively reduce equipment investment costs. It also has significant current-limiting effects, which is important for the dynamic and the thermal stability of the power grid during short-circuit accidents. Currently, load switch and fuse combination structures are widely used in ring main units and fabricated substations, domestically and internationally. For transformer protection, it is more effective than using a circuit breaker as it shortens fault clearing time and reduces the risk of transformer explosions. Let's introduce the structure requirements of load switches based on the working characteristics of load switches. The structure requirements are as follows. The first is there should be a visible gap when the load switch is in the open-up position. There should be a visible gap, so no isolating switch is needed. In series with the load switch, During electrical equipment maintenance, just opening the load switch is enough. Second, it should withstand many operations. The load switch should endure as many operations as possible without requiring contact maintenance and replacement of arc extinguishing components. Third, it should be able to close short-circuit current. The load switch is not required to break short-circuit current, but it should be able to close short-circuit current and meet the requirements of dynamic and thermal stability. Of course, this requirement does not apply to load switch fuse combination switchgear. Modern load switches have two distinct characteristics. First is they have three positions, namely closed, open, and grounded. The second, the arc extinguishing system is separated from the current carrying system. The arc extinguishing system does not bear dynamic and thermal currents, while the current carrying system does not participate in arc extinguishing. Load switches, based on their arc extinguishing methods, can be divided into oil load switches, magnetic load switches, air blast load switches, gas generating load switches, SF6 load switches, and vacuum switches. Among these, oil load switches and magnetic blow load switches have been phased out. We will introduce four commonly used load switches. Let's first look at gas generating load switches. Gas generating load switches use solid gas generating materials that produce gas under the action of an arc to extinguish the arc. They belong to self-extinguishing types. The arc extinguishing chamber of gas generating load switches has two structures, tubular and plates. Let's first look at the tubular arc extinguishing chamber. Its structure and the breaking process are shown in the figure. In this arc extinguishing chamber, the chamber itself does not move. Only the isolating knife and arc knife moves. When breaking large currents, the gas blowing method is used, and the arc energy is dissipated through the principle of convection. When breaking small currents, the large surface area of plastic wall cooling effect is used. The arc energy is converted into the decomposition heat or absorbed heat of the plastic outer layer. Now let's look at the plate arc extinguishing chamber. Its characteristic is only the arc knife and the main knife move. The arc extinguishing plate is fixed. As shown in the figure, it consists of a load switch and fuse. Its basic structure is as follows. The conductive circuit includes moving contacts, fixed contacts, arc extinguishing tubes, and fuses. The moving contacts is composed of two parallel blades. The fixed contact has a guide plate and a fixed on the post insulator. The base is equipped with 9 post insulators to support the conductive circuit and the fuses of each phase. The operating mechanism is installed beside the base with opening and closing mechanisms. The open spring is installed in the middle of the base. Additionally, there are trip mechanisms and automatic interlock devices. For safety, a reliable mechanical interlock is used between the load switch. That's all for today's class. Thanks for listening.